Hi guys, we are continuing our work on inequalities, solving inequalities, and as you know, we go about solving inequalities the same way that we solve equations, but we are going to continue looking at inequalities. Now, what we're looking at right now is determining multiplication patterns involving inequalities. So the first thing is, how does the position of a number on a number line determine whether it's greater than or less than another number? So let's draw a quick number line. And if we have 4 and 2 on a number line, here's 2, 3, 4. How does the position determine whether it's greater than or less than a number? Well, 2 is to the left of 4, therefore it is less than 4. Let's look at -4 and -2. Here is -2, -3, and -4. And again, -4 is to the left of -2, and -4 is less than -2. So now what we're going to do is we're going to complete this table and determine if this inequality, 12 is greater than 6, remains true based on multiplying by these various integers. So let's start with 12 times 3, which is 36. And then let's multiply 6 times 3 is 18. And 36 is greater than 18. That is true. Let's multiply both sides by 2. 12 times 2 is 24. 6 times 2 is 12. 24 is greater than 12. So by multiplying by 2, the inequality stays the same, or it remains true. Let's multiply both sides by 1. 12 times 1 is 12. 6 times 1 is 6. 12, in fact, is greater than 6. All right, now let's multiply both sides by -1. -1 times 12 is -12. -1 times 6 is -6. Is -12 greater than -6? No. -12, in fact, is less than -6 because -12 is to the left of -6. So the sign actually switches. Okay, let's do another one. It turns around. -2 times 12 is -24. And -2 times 6 is -12. And is -24 greater than -12? No, it's a smaller number. The absolute value is bigger, but -24, in fact, is less than -12. So, when we're multiplying by a negative number, what's happening to the sign? Let's do another one. -3 times 12 is -36. -3 times 6 is -18. Does this inequality with the greater than sign remain true as it did when we multiplied by positive integers? No, it does not. -36 is less than -18. Okay, let's go down. When we compare the inequality signs with the inequality sign in 12 is greater than 6, when did the inequality sign stay the same? Well, it stayed the same when we were multiplying both sides by 3. 3 times 12 is greater than 3 times 6. Okay? So it remained the same. But when we did -3 times 12 and -3 times 6, the direction of the sign actually switched in order to make the inequality true. So we have -3 times 6. Let's squeeze that in there. Okay, so what are the implications of this? Let's go on to division. We're going to complete the chart again with determining if the inequality stays true. 12 is greater than 6. Well, let's divide both sides by 6. 12 divided by 6. And let's do 6 divided by 6. Does it stay true? 12 divided by 6 is 2. 6 divided by 6 is 1. 2 is, in fact, greater than 1. So the inequality sign stays the same. Let's divide 12 divided by 3. 12 divided by 3. And 6 divided by 3. 12 divided by 3 is 4. 6 divided by 3 is 2. 4 is greater than 2. The sign stays the same. Let's do 2. 12 divided by 2 and 6 divided by 2. Let's evaluate it. 12 divided by 2 is 6. 6 divided by 2 is 3. 6 is, in fact, greater than 3. Now, let's switch our integers to negative. 12 divided by negative 6. And then let's do 6 divided by negative 6. And 12 divided by negative 6 is negative 2. 6 divided by negative 6 is negative 1. Is negative 2, in fact, greater than negative 1? We know that negative 2 is less than. It's to the left of negative 1. Let's do 12 divided by negative 3. And let's do 6 divided by negative 3. 12 divided by negative 3 is negative 4. 6 divided by negative 3 is negative 2. Is negative 4 greater than negative 2? No. Negative 4 is, in fact, less than negative 2, okay? Let's do one more. Let's evaluate 12 divided by negative 3. And then let's do 6 divided by negative 3. 12 divided by negative 3 is negative, hold on. Oh, this says multiply. Okay, these should actually, guys, say divide. This is a typo. Each of these should say divide. And then it says negative 3 again. So we already did that. All right, so let's just do a little bracket, divide here. Okay. These should all say divide. Okay, so compare the inequality signs. We're doing that. But again, when we started dividing by a negative, just like when we're multiplying by a negative, we had to actually flip the direction of the inequality sign to make the inequality true. Let's go to the next page. All right, so here we have negative 5 times s is less than or equal to 25. So because we're multiplying the variable by a negative number, we need to, in fact, switch the direction of the sign, okay, when we get our answer. So let's divide both sides by negative 5. Negative 5 divided by negative 5 is s. But because we're dividing by a negative, we need to switch the direction of the sign. X is greater than or equal to negative 5 instead of less than, because we're dividing by a negative. Let's graph that. We have negative 6, negative 5, and negative 4. So our solution set for s is greater than or equal to negative 5. So we're going to go to the right. Let's do 7a divide 7a. 7 times a is less than 21. So we're multiplying by a positive. So we leave the sign as it is. 7 divided by 7 is 1a is less than negative 3. So all the values that make this solution, this inequality, true are in fact less than negative 3. So that's going to be negative 4 and beyond. So that's going to be an open circle. And we'll make, oh, I don't like that. We'll make this open circle. All right, and this is negative 2. Let's look at y. Some value of y. Y is divided into negative 4 parts. Well, we want to know what y is. We need to multiply 4 back in, okay? So y divided by negative 4. We multiply 4 back in on both sides of the inequality. Do the opposite operation to dividing, which is multiplying, or if we divide a fraction, we know the algorithm for dividing fractions is multiplied by the reciprocal. So negative 4 divided by negative 4 is 1y. But what do we have to do to the sign? We need to switch the direction because we're dividing by or multiplying by a negative. So instead of y being greater than, it's going to be less than positive 12. Y is less than positive 12. Okay? So again, we have negative 1/4 y is greater than negative 3. To get y by itself, we're dividing here by negative 1/4. We want to multiply both sides by negative 4, or just multiplying by the reciprocal. So let's graph that. We have a 12. We have a 13. We have a 11. Y is less than 12. So all the numbers less than 12 make that solution true. K, some value K, is divided into 3 parts. If we want to know what K is, we have to multiply K by 3. Multiply both sides by 3. Because this is just 1/3 of K is greater than or equal to negative 2. If we want to know what the complete K is, we have to multiply by 3. Or K divided by 3, the opposite of division is multiplication. Multiply both sides by 3. These 3's divide out, so we're left with K is greater than or equal to negative 6. We didn't switch the direction of the sign because we're dividing by a positive. So now let's go ahead and graph this. We have a number line here, negative 6, negative 7, and then we'll put negative 5 here. We have greater than or equal to, so that's a closed circle, and all the values to the right of negative 6 make the solution set true. Okay, so now let's go ahead and do a two-step equation. Here we have, actually, we'll do some practice problems. Hold on, guys.